Today we are going over some fundamental model welding concepts in Tekla structures. Towards the end of this video, we will learn how to export welded assemblies from the model into an AGT file which the fabricator will then import into their robot welding equipment. Before we begin talking about adding welds to the model, I would like to go over the different options for displaying model welds. To access these options, double-click on your view, and click on the Display button. From here, you will see that you can toggle the visibility of all welds that are not part of a component in the first column. In the second column, you can toggle the visibility of welds in components only. Under the drop-down menu, you will see three different options. The first is Fast, which only shows a little teal weld symbol. You can select the weld and its properties will show up in the Properties pane. The second is Exact, which shows the weld symbol along with a visual representation of the weld itself. The third is Exact, No Weld Mark, which only shows the weld itself. I personally like to use this third option because it allows me to visually see which parts are welded, and it also keeps your model views clear and free of clutter. To produce an AGT file, the first thing we need to do is make sure that we have joined our assemblies using model welds. You can see here on this shear plate connection that we have a fillet weld on both sides of the plate to column flange. You can also see that we have a fillet weld all around at the column base plate. Just about every component will have an option in the dialog box for setting the model weld parameters. You can access this by double-clicking the component, then clicking on the Weld button. From here you will see that any weld in the component can be manipulated as needed. For example, let's say the engineer calls for a 5/16 fillet weld both sides. We would find which weld number we need to manipulate by looking at the picture diagram. In this case, the shear plate weld is number 5, so we would go to weld number 5 and change the size to 5/16. Then select the component, click Modify, and you can see the weld has now changed size. Not all model welds can be achieved using components, and there will undoubtedly be situations where manual welds will need to be added to the model, like this bent plate pour stop for example. There are two different ways to do this. The first is creating a weld between parts. You can achieve this by clicking on the command ribbon and selecting Create Weld Between Parts. If you look down in the lower left-hand corner of your view screen, you will see we first select part to weld to and then we select the part to be welded. We can now see that a weld has been added between the beam top flange and bent plate. We can also see that the main part for this assembly is red, and the secondary parts are yellow. The first part you pick when adding manual welds will usually become the main part of the assembly. For checking purposes, select and right-click on any part in the assembly, go to Inquire, and then Assembly. You will now see the main part is highlighted red and all secondary parts are highlighted yellow. Now that we have a weld established in the model, we can manipulate it using the Property pane. First, we need to make sure the weld is located on the correct side of the plate. Now, in this case the default position of the weld is not correct. We need the weld to be located along the length of the bent plate. We can achieve this by using the drop-down box under Position. The weld's position is set based on your UCS, or User Coordinate System, shown in the lower right-hand corner of your screen. In this case, if we select the weld and set its position to -Y, we can see that the weld has now moved to the -Y side of the bent plate. Now that we have set the proper weld position, let's say we want a 1/4 inch fillet on both sides in a 2-on-12 stitch pattern. First, select the weld. We will click the drop-down box above line and set it to fillet. We will then set the weld size for both above and below line to be 1/4 inch. We can now click the drop-down box under Shape, either select Chain Intermittent or Staggered Intermittent, depending on what style of stitch weld we need. We also need to set the weld length and the center-to-center distance between each weld segment, which is achieved under the length and pitch boxes. Once everything is set, click the Modify button and you will see that your weld is now updated in the model. Now that we have gone over adding basic welds to the model, we can talk about polygon welds. A polygon weld is essentially a weld that follows a polyline. This is especially useful in instances where a weld on 3 sides is required. Maybe a weld return is called for by the engineer, or maybe even a specific length of weld at specific locations are required. For demonstration purposes, let's add a polygon weld to this column cap plate. Click on the Weld button and go to Create Polygon Weld. Just like before, select the part to weld to and then the part to be welded. Then pick the points you want the weld to pass through. In this case we are welding the cap plate to column on 3 sides. After you have picked your points, press the middle mouse button and you will see that a polygon weld has been added to the model. Once you have a weld checked and established in the model, you can then move, copy, and manipulate the weld itself just like you would with any other part in the model. In this case we will mirror the weld to the opposite side of column web. Then we can select both welds and copy to the other column. Now we can apply polygon welds to the vertical stiffener plates. First add a polygon weld to one side and set its properties to fillet weld on both sides. Remember, you can do this from the property pane when the weld is selected. You will notice that the part you are welding to does not automatically become the main part of the assembly like it would when adding a simple weld. Now we can copy welds to the other stiffener plates, or we can simply copy the stiffener plates and the welds will copy with them. Before we finish up this video and talk about exporting to an AGT file, there are 2 things I would like to mention. First, it is very important that all welded parts are physically touching each other in the model. If you look closely you will see in this model that my shear plates are touching the column flanges, my bent plate is touching the beam top flange, and my stiffener plates are touching the bent plate. Taking extra care to watch the snapping icons in your modeling will prevent any small gaps between welded parts, which will in turn prevent errors in the AGT file that we will export. Secondly, I want to talk about checking welds in the model and making sure they match the shop drawings. I have had success with this by checking the model welds using a yellow, or light-colored, highlighter on the contract drawings. When checking the shop drawing welds, I will re-highlight the same weld callouts on the contract drawings using a darker highlighter color. Orange works well for me. Of course, everyone is free to detail in whatever way is most efficient for them. This is just a suggestion that has worked out very well for me. Now that we have all our parts welded and everything is checked, we can export all this information to an AGT file. In the component search pane, we can search for AGT. Double-click on the AGT Export icon and the dialog box will appear. You will see that the default export path is going to be the main model folder. This can be changed or left as is. Click on the Advanced Settings tab and make sure that Import Welds from Tekla, as well as the Import Bolted Assemblies boxes are both checked. Next, we will want to click the button next to Selected, since we only need to generate a file for beams and columns that will be robotically welded. Next, select the steel assemblies we want to export and be sure to use the Select Assemblies selection mode. With our steel selected, click on OK. There will be a reminder box that pops up letting you know to save the model and to reopen the model without saving after the export is complete. Save the model and click Yes. After the export is complete, reopen the model without saving. You can then find AGT file by going to the main menu and clicking on Open Model Folder, which will open the main model folder. From here, you can sort by file type and find the .agtx file. This is the file that you will send to the fabricator, which they will then input into the robotic welding equipment. I hope you have found this video helpful. Feel free to contact me via email at steven@sedetailing.net.